Good evening, everyone. We are here to present our circuit analysis and power consumption interpreter. This Python-based tool is designed to help students, engineers, and hobbyists analyze electrical circuits by calculating key values like resistance, current, power, and capacitance, both for resistors and capacitors in series or parallel configurations. Our goal was to create a simple tool that makes circuit analysis, easier and accessible. Whether you're a student learning about Ohm's law or an engineer optimizing a circuit, this tool really aims to provide a quick and accurate calculations, along with a user-friendly interface. So, let's get right into it.
So let's walk you through the core features of the tool. Here are the some of the key function it offers. First, user input. User can enter values for resistor or capacitors and choose between different units like ohms, microfarads, or kilo ohms. The second one is circuit configuration. The tool allows user to analyze circuits in either series or parallel configuration. And next is voltage drop and current calculation. The program calculates the voltage drop across each resistor and the current flowing through the circuit. And error handling. It ensures no incorrect values like zero resistance or capacitance are entered and handles error gracefully. Save results. User can save the results to a text file for future reference. And lastly, for future enhancement, we have plans to add features like capacitors, charging simulation, and graphical outputs. And now, let me show you how the program works in action.
Alright, now let's dive into analyzing resistors. When you select option 1, resistors, uh, resistor from the main menu, the program will guide you through several steps. Here's how the process works. The first step is to choose the power source. The program asks whether we're working with an AC or DC circuit. For this example, let us choose DC. Now that we've chosen the power source, the program will ask us to enter the voltage of the power supply. Let's assume we're working with a voltage of 12 volts. Once we've entered the voltage, the next step is to select the unit for resistance. The program will give us options like ohms, kilo ohms, and milliohms. For this example, we'll choose ohms. Now we'll need to choose the resistor configuration. The options are single resistor, resistors in series, and series in parallel. Let's go ahead and select option 2, resistor in series. Next, we'll enter how many resistors we have in series. Let us say we have 3 resistors in the circuit, so we'll enter 3. Now we'll enter the resistance values for each of the 3 resistors. For the resistor 1 is 10, for 2 is 20, and last is 30. The program will now calculate the total resistance by simply adding up the resistance values for each resistor in series. Now let's take a look at the voltage drop across each resistor. Since the current is the same across each resistor in a series circuit, this confirms that the total voltage drop adds up to the supplied voltage, which is 12. 2 plus 4 plus 6. Finally, we can save this result to the text file for future reference. The program will automatically store the calculated values and voltage drop. And that's how the resistor analysis works. It is easy to follow and ensure that all the key calculations like total resistance, current, power, and voltage drop are handled for you. And let's proceed to the next one.
And now let's return to the main menu and explore option 2, which is capacitors. Um, Again, we choose the unit options include microfarads, nanofarads, and picofarads. For this example, we'll just use microfarads. Next, we would choose a capacitor configuration, which is one capacitor in series or two capacitors in parallel. Let's pick option 2, which is capacitors in parallel. Now we will enter the number of capacitors. Let's say we have 3. And then we would each enter the capacitance value of each capacitor. For capacitor 1, we would have 10 microfarads. For 2, we would have 20 microfarads. and for 3 we would have 30 microfarads. The program calculates the total capacitance for capacitors in parallel by summing them, which will show the result of the total capacitance, which is 60. And finally, the program prompts us to save the capacitor analysis result as well. At any time, you can return to the main menu and choose option 3, which is um, view saved circuit info. Okay. This opens the circuit analysis report text file showing a history of saved resistor or capacitor analysis, including timestamps and component values. And that's basically how the component analysis tool works. It supports resistor and capacitor circuits, calculates total values, voltage, current, or charge as applicable, save all outputs to a result file for future use, and allow users to review past results from the main menu. And now we will go into the next part.
The program was built using Python, a powerful language that is easy to use for such tasks. The program runs in a console-based environment, which makes it simple and accessible for anyone to use. We also used basic libraries like datetime for logging errors and saving results. We created several functions to handle specific tasks. The first one is calculate series resistance. It calculates total resistance for resistors in series. Next, calculate parallel resistance. It calculates total resistance for resistors in parallel. Then next, calculate series capacitance. It calculates total capacitance for capacitors in series. Next, calculate parallel capacitance. It calculates total capacitance for capacitors in parallel. Then next, display voltage drops. It shows the voltage drops across each resistor in the circuit. Next, log error. It logs errors in a file for troubleshooting. Then the last, save to file. It saves the result of the analysis to a file.
Looking ahead, we plan to add more advanced features such as capacitor charging and discharging simulations to show how the voltage across a capacitor change over time. Next, graphical outputs to visually represent the circuit and its components for better understanding. Third, enhance user interface for more interactive experience, possibly incorporating in a GUI or graphical user interface.
And that sums it up for our project, which is the wait, the circuit analysis and power consumption interpreter. This project has been a great learning experience for us in applying Python to real-world problems. We believe this tool is very useful for students, teachers, and anyone looking to simplify circuit analysis. And that's pretty much it. Thank you for watching our video, and I hope you learned a lot. Thank you.